All right, kids. Today we're going to be doing topic 3, which right here, on our first review packet. So if you notice right here, I've gone ahead and listed all of the first 20 perfect squares, and the last few I labeled them so you'll know which ones they are. And then the first 12 perfect cubes, which means to the third power, like 2 to the third power equals 8. So we're going to use that to do this first part of the page. So go ahead and make sure you copy those down. Excuse me. And then we'll evaluate these. I don't know if you remember, but in class we talked about when you see this symbol right here, that's the radical sign. When you see the symbol by itself, it means just the positive square root. Because as you remember, -7 times -7 also equals 49. Okay, so that's true. However, when you just see the radical sign by itself, we only want the positive square root. So this is going to be +7. So on this one, if you'll notice right here, they have shown us a negative sign out there. So on this one, it's actually calling for the negative square root of 256. So if we come up here, we find the square root of 256 is 16. So this answer is going to be, that's hard to see, -16, because the negative sign was on the outside. All right, so let's look at a cube root. And so we have the cube root. You have to look out here to remind yourself, okay, that's the cube root. I think with the last quiz we took, some people forgot to look there. And so we're going to look in our cube root list right here, and we find 216. So that's going to be, let's see, 1 cube, 2 cube, 3, 4, 5. This is 6 to the third power. So the cube root of 216 equals 6. All right, so I'm going to leave you the rest to do by yourself, but let's come down here starting at problem 12. We did this in class as well. Estimate, that's great because that means you don't need a calculator. Oh, it's the nearest 10th. Maybe you do need a calculator. So let's work on that. So if you put in, remember if you have your calculator, you're going to find the square root sign. And if you do the square root of 78, it says, remember, it's approximately 8.8317 and a whole bunch of numbers, okay? It says to the nearest 10th. We need to make sure that we are remembering the 10th place is the first place behind the decimal. So this is the place I want to round to. So if you recall the things that we did in class, you look next door, and that is less than 5. So our answer is going to be approximately 8.8. We're going to leave it as an 8 because the number behind it is less than 5. So those aren't too bad to do. Just remember when you get down here, you have a negative sign. So please make sure you have all that copied down because I have to erase it before I can scroll up and do the rest of the page. Remember, this is topic 3 in packet 1. All right, so I'm going to clear this page. Oops, clear all drawings. Oh, man, I don't want to do that. Okay, I don't know if I can't remember if I need that for the rest of the page, so I'm going to leave that list right there. No, I have to undo all of it. I'm sorry, I'm talking to myself. Okay, let me scroll. Oh, yeah, this is totally different. The real number system. Okay. So, by the way, here's my little positive for you. You can do it. I know you can do Algebra 1 next year. We just have to work at it. So the real numbers, remember the real numbers are numbers on the number line. I'm sorry, my handwriting is so messy. Oh boy, that looks terrible. Okay, so irrational numbers. Irrational numbers. What do you do? See if you remember what that is, first of all, before I write it. Okay, so irrational numbers, we're going to write a couple of things. Okay, number one, irrational numbers cannot be written as a fraction. They cannot. It's hard for me to write on this. Okay, that's the first thing. The second thing about those irrational numbers is that they are decimals that never end or repeat. Whoops. Whoopsie daisy. Where's my eraser? There it is. Or repeat. So those are irrational numbers. If you cannot write it as a fraction, then it is irrational. So rational numbers can be written as a fraction. So we're going to do that symbol here, A over B, when B is not 0, because you can't divide by 0, remember that. Or decimals, like 1.25, or regular numbers like 14. Okay, all of these can be written in fraction form. That's the key. A rational number can be written as a fraction. Integers, if you remember, are the whole numbers and their opposites. And then whole numbers. I'm just going to write the list because it's easier for me to do, I think. If you remember, the whole numbers start at 0, and then it's your positive numbers. Let's remember, they're whole numbers, so no fractions, no decimals, just like whole cakes, 1 cake, 2 cakes, etc. And then the natural numbers, if you remember, we said those are the counting numbers. So those are like when you start learning to count when you're little, you start with 1, 2, 3, and then go on. Okay, so the only difference here between the whole numbers and the natural numbers is the addition of 0 into the group. And then once you move up from whole numbers to integers, you have all of these positive whole numbers plus their opposites, which means all the negatives. And then rational numbers, anything that can be written as a fraction. And I'm going to put in a negative here just to remind you that rational numbers can be negative. All right, so if we look down here at our diagram, please pause your video and write all that stuff down so you can refer back to it, because I have to erase it so I can scroll up. And I wish I didn't have to do that, but I do. All right, there we go. Okay. All right, so if we're looking at this, in this whole box, all of these things are real numbers because all of them are on the number line, okay? So let's start with letter A. We're gonna do this list together, then I'm gonna leave you to do the right-hand column. Except for maybe this one. Okay, so 7. So we're gonna put it just in one circle so it says the smallest set. So 7, because that's a counting number, that's a natural number, that's going to go here. It's all of these things too, but the instructions say put it in the smallest set. And so letter C is negative square root of 36. Well, we can answer that because now we know the square root of 36 is 6, so that's going to be negative 6. All right, so that's not a counting number, and it's not a whole number because whole numbers are positive, if you recall. So that's going to have to go right here, and that's going to put C right here. So let me go back because I put the wrong thing here. Just realized that. That should be an A. Okay, so now let's do this one. They have given us no indication here what's happening. They didn't tell us it repeats. So all we know is that this is the number 6.0487, the end. So that's a decimal that does have an ending, which means we can make it a fraction. If we set it in fraction form, it'd be 6 and 487 ten-thousandths. That can be a fraction. So that's going to be a rational number here. E. Remember, if it's a decimal, you cannot put it in the integer spot or the whole number. All right, so now we have the square root of 196. If you look up at the top of your page, you should know that the square root of 196 is 14. Since we can simplify that to a positive whole number, we're going to put that right here. It is an integer, but the smallest group it goes in. I don't know why I did that. I'm so insane. That's a counting number. So we're going to put that right here, G, because we can count with that. 0. So this seems to be a tricky one. But if you remember our list up at the top of the page, 0 is the very first whole number. So I is going to go right here. All right, so negative 19. It's got a negative in front of it. That means it's got to be an integer. And let's do this one. That's the same as the square root of 1 over the square root of 16. So now we know the square root of 1 is 1. The square root of 16 is 4. So that's the fraction 1/4. So that has to be a rational number because it's a fraction. Remember, integers are the whole numbers and their opposites. Okay, by now, I was going to do J for you, but it should be easy for you since we've already had a lesson on negative exponents. Oh, we'll do it anyway. Okay, because I'll make sure you get it right. Remember, when you have a negative exponent, it doesn't mean a negative number. It means the reciprocal of the base. The base is 8. The reciprocal of base is 1 over 8 to the first power. Once you find the reciprocal of the base, that exponent becomes positive. So now we have a fraction 1/8. If you were tempted to put it as an integer because you saw that negative 1, remember, it doesn't make the number negative. So now we know J is a fraction. It has to go here. All right, so that's this page. I'm going to make in a few minutes. I'll make another one for the next page. But I believe that concludes review packet 1. All right, so I hope you're having a wonderful day. And hope you're understanding this work. If not, please make sure you let me know. All righty.